Welcome to the video. In this tutorial, we'll be covering the basics of simple cloth simulation in Unreal Engine 5.5. Everything will be done within Unreal Engine and without the need to jump into any third-party modeling tools. There's lots of information on this topic that I wanted to cover, so it's a bit longer than my previous tutorials. Therefore, I've broken it down into 3 parts. In part 1, we'll cover the basics of what you need to do to create a simple towel simulation. I'll also cover some features and advanced settings to help improve the look and accuracy of your simulations. In part 2, we'll take things a bit further and create a simple flag simulation with real wind effects. And in part 3, we'll model and simulate a working curtain in Unreal Engine using the modeling tools. The chapter links for the tutorial are in the description if you need to review or jump to a specific section. Lastly, you'll find a link in the description to where you can download the entire project for free in case you want to follow along using the same files in the video. As you work through each part of this video series, I would highly recommend that you create a new level for each one. While making this video, I discovered that Unreal Engine will crash if you try to simulate more than 3 or 4 meshes at the same time, at least in my case. Your situation might be different depending on your system specs. First, let's start by creating a new folder to hold all our cloth meshes. We'll call it cloth_meshes. Next, let's go into modeling mode and create our towel mesh. We'll point the modeling tools to our current folder. All we need is a simple rectangle shape, and we'll set the width to 100 and the depth to 200. Now, in order for our towel simulation to look as smooth as possible, we'll need a decent number of triangles in our mesh, so subdivisions of 40 and 40 should be enough. You don't want a super dense mesh because it will severely impact the performance of the cloth painting editor as well as your final simulation. We'll place it in our scene and click Accept. Let's exit modeling mode, and we'll also delete the mesh from our scene. You'll see why later. Let's also rename our mesh to SM_towel. Double-click on your mesh to bring it up in the mesh editor. As you can see, here is our triangle count for this mesh. I found that a count of under 5,000 triangles is a good compromise between quality and performance in this example. Since we're here, let's go to the Details panel and assign our towel a material that I've already created. Click Save and exit the mesh editor. Now, in order for us to convert this into a cloth simulation, we need to convert our static mesh into a skeletal mesh. To do this, just right-click on your static mesh and select Convert to Skeletal Mesh. All the default values are fine, so just click on Convert. You'll now see 2 additional files created in your folder. One is a skeletal file, and the other is our skeletal mesh. Double-click on the skeletal mesh file to bring it up in the skeletal mesh editor. Make sure you have a clothing tab in your editor. If you don't see it, go to the menu bar and click on Window. Then select Clothing, and that will bring it up for you. Right-click on your mesh and select Create Clothing Data from Selection. Then click Create. Right-click on your mesh again and select Apply Clothing Data. Now we can start the cloth painting process. At the top, click on Activate Cloth Paint. Then click on your skeletal mesh in the Clothing tab. This puts us into painting mode. You'll notice our mesh turns pink. This means it's not been painted yet. What we're going to do is tell Unreal which parts of our mesh we want to simulate as cloth by painting those sections. Now, in this towel example, we want the entire towel to be simulated, so we'll be painting the entire mesh. First, in your clothing tab, look for the paint value setting. When you paint your mesh, you can assign different parts of your mesh a different paint value. This value represents the number of centimeters the painted section of cloth will be simulated. Confused? Let me show you what that means exactly. The default paint value is 100 centimeters, but let's drop that down to 25 for our little demo. Right below that is brush radius, which, as in most paint applications, this is the size of your paintbrush. Let's change this to 50, which will help us cover a lot of area quickly. Now go over to your mesh and hold down your left mouse button and paint your entire mesh. This will be the area that will be simulated. Make sure you cover the entire mesh. Next, click the Deactivate Cloth Paint button at the top to take us out of painting mode and watch what happens. As soon as you exit paint mode, Unreal simulates your cloth. What happened is that gravity took control and your cloth began to fall to the ground, but then suddenly stopped. It stopped after it fell 25 centimeters, which was the paint value we painted onto our entire mesh. So the simulation terminated. So think of paint value as a simulation bounding box for your mesh. In our case, it's 25 centimeters in the X, Y, and Z directions. Once any part of our mesh crosses outside that distance, the simulation stops. Let's try another example. This time we are only going to paint half of our mesh. So click the Activate Cloth Paint button again to put us back into paint mode. Now set your paint value to 0 and repaint your entire mesh again. It should turn pink again, effectively returning it to an unpainted state. Now reset your paint value to the default value of 100, and this time we are only going to paint half of our mesh. Now let's exit paint mode by clicking on the Deactivate Cloth Paint button. As you can see, the section of cloth that we painted that still resides within our simulation bounding box of 25 centimeters remains in simulation mode, while the section of cloth outside that box no longer simulates and returns to its original shape. So you might be thinking, why not just set a really high paint value so I don't have to worry about any issues like this happening? You absolutely can do that. In fact, you'll see this in most cloth simulation tutorials where they recommend a value of 1000, but they don't tell you why. But if you want to optimize the performance of your simulation, it's probably a good habit to only paint a value that you need. Otherwise, if you're just playing around, 1000 is okay too. Some other points about painting that I want to mention. If you want to repaint with a different paint value, you don't have to first repaint with a value of 0, then paint again with your new value. I just prefer starting with the pink shading so I don't miss any areas when I repaint. Also, the painted sections are not always just white, but can show as shades from black to white, which represent different paint values being applied to those areas. You'll see this if you use the gradient brush, where the darker areas will simulate less than those closer to white. Before we continue, let's repaint our mesh so it simulates freely. Set the paint value to 1000 and repaint the entire mesh. When you're done, click the Deactivate Cloth Paint button to run the simulation. This time, you'll notice your mesh falls out of frame. That's to be expected because the floor in the editor has no collision shape assigned to it, and our mesh is set up to simulate within 1000 centimeters, so it's going to fall for quite a distance, 10 meters, before it exceeds our simulation bounding box. Click the Save button and close the Skeletal Mesh editor. Now, let's play with our new towel mesh in our scene. Drag your skeletal mesh towel into your scene like this. Now, in order for our skeletal mesh to interact with objects in our scene, we need to enable two settings. So with our skeletal mesh selected, go to the Details panel and search for Cloth. Enable these two settings, Collide with Environment and Force Collision Update. These must be enabled in order for your cloth mesh to interact with other actors in your scene. Let's try it out. Click on the white play button to start the simulation. It just passes through the default scene floor. That's because the scene floor doesn't have collisions set up by default. That's for overall editor performance reasons. Click the stop button to end the simulation. Now, it just so happens that the default scene primitive shapes do come with collision assigned to them. So let's grab a sphere actor and place it in our scene. Now, reposition your towel mesh so it's flat and slightly above the sphere, not too high above it though. The sphere should be in the center of the towel. Press the Simulate Play button. It should simulate nicely over the sphere. If your sphere tears through the towel, stop the simulation and try lowering your towel as close to the sphere as you can without touching it, and then play the simulation again. Congratulations! You now know the basics to creating a simple cloth simulation. In the next chapter, we're going to briefly cover a few advanced features and settings, so stick around. So let's first swap out our sphere with a cylinder shape and position it so it can act like a towel rod for us. I already have one prepared. Now run the simulation. What if you wanted to save a copy of the mesh in that pose so you can reuse it in, say, an ArchViz scene or cinematic that you're working on? Well, that's easy. While the simulation is still running, click on your mesh in the scene to select it. Then go to the menu bar and click on Actor and select Convert to Static Mesh. Pick a folder to save it to and give it a new name. Then click Save. If you have several simulated meshes and you want to save them as a group into a single mesh, just hold down the Control key to select each one. Now stop the simulation. Go to the folder where you saved your new mesh and drag it into your scene. Sometimes you'll notice that the pivot point is a bit off on this new mesh. That's an easy fix. With your mesh still selected, go into modeling mode. Click on Xform and select Edit Pivot. Click on the center button or reposition the pivot manually where you want it, then click Accept. That new pivot location is now stored with the original mesh, so every time you drag it into a scene, it will be right where you placed it. What if you wanted to improve the accuracy of your simulation? Bring up your skeletal mesh in the Skeletal Mesh Editor again. In the Clothing tab, look for the Config section and expand it. Expand the Cloth Configs section. Expand the Chaos Cloth Shared Sim Config section. And finally, expand the Simulation section. By slightly bumping the iteration and subdivision counts, you can smooth out your simulation in exchange for lower performance. A good starting point is 6 for iteration count and 2 for subdivision count. Don't forget to click on Save when you're done. When you start getting closer to 10 for these values, you can lock up or even crash Unreal Engine, so adjust accordingly. What if you wanted to simulate specific types of cloth, like leather or silk? You do that in the Chaos Cloth Config section. If you hold down the Shift key when you click on this section, it will expand all child sections also. As you can see, there are a ton of properties you can adjust here. Epic does provide some examples in their Content Examples project that you can download from Fab for free. Once you open the project, go to the Maps folder. Then open the Physics folder. Then double-click the Physics cloth level to open it. If you scroll down to the third exhibit, you'll see some settings for 4 different types of cloth. I provided a screenshot of these in my downloadable PDF file. You'll find a link in the description. Unfortunately, there are no predefined settings for every type of cloth. So if you need to simulate cotton cloth, for example, you'll have to play around with some of the content example settings to get something that looks right to you. So what if you have a static mesh you made or downloaded from Fab and your cloth is not interacting with it? It's just passing right through when you run your simulation. How do you fix that? This is happening because your static mesh is missing a collision shape. Here's how you can add one to it. In this example, I used the modeling tools in Unreal to create a very simple table. Let's open it up in the mesh editor by right-clicking on the mesh and selecting Edit SM_table. If you click on the collision dropdown, you'll notice that Remove Collision is disabled. That means this mesh doesn't have any collision shape assigned to it. So let's assign one. We'll use Box Simplified Collision since our table is essentially a box, so that shape will fit well for us. In the Details panel, scroll down until you find Collision Presets. And verify it's set to Block All. Then for collision complexity, choose either Simple and Complex or Use Simple Collision as Complex. I'm going to choose Use Simple Collision as Complex. In my testing, I found that cloth collision simulations only seem to work when the mesh has some form of complex collision enabled. Now, let's run a simulation with our towel to test it out. And as you can see, it works perfectly. Just some final tips. If you've assigned a collision to your mesh, but your cloth still falls through it, it could be due to the fact that the collision shape is too close to the mesh. To fix that, go back to the mesh editor and under Show, check off Complex Collision. Select the collision shape. That will give you access to your transform controls. Just scale the shape up so it's slightly larger than the mesh. Click Save and rerun the simulation to see if that fixes it. If that doesn't work, then try assigning an auto-convex collision to it. This type of collision works really well with meshes that have concave surface features, like a block-up Swiss cheese, for example. To apply it, first remove your existing collision by going to the Collision dropdown and selecting Remove Collision. In the same dropdown, select Auto-Convex Collision. You should then see the Convex Decomposition tab appear. The default values are fine, so just click Apply. Then click Save and rerun the simulation. In my testing, the auto-convex collision worked every time with no issues. It's especially helpful if your mesh is not a primitive shape, like a sphere or a box, etc. It is the most expensive form of collision, but if you're using it in a cinematic and you'd rather just use that all the time, it should be fine performance-wise for you. It should be your last choice if you're making a game due to the performance cost it incurs. That concludes part 1 of this video on the basics of cloth simulation. In the next part, we'll take what we just learned and create a simulation of a flag blowing in the wind, so I hope you'll stay to watch that also. Welcome to part 2 in this cloth simulation series. In this section, we're going to create a simulation of a flag blowing in the wind. If you haven't watched the previous tutorial that covers cloth simulation basics, I highly recommend you check that out first. It's going to provide you with a good foundation and understanding of what we'll be covering in this section. For those of you that came from the previous tutorial, this section will look very familiar to you in the beginning. Let's start by jumping into our cloth meshes folder we created earlier. Next, let's go into modeling mode and create our flag. We'll point the modeling tools to our current folder. All we need is a simple rectangle shape that's 100 by 100. Subdivisions of 40 and 40 should be enough to give us a smooth flowing flag. Click Accept, and let's exit modeling mode, and we'll delete the mesh from our scene. Let's rename our mesh to SM_flag. Double-click on your mesh to bring it up in the mesh editor. I'm going to assign our flag a material that I already created. Click Save and exit the mesh editor. Now let's right-click on our static mesh and convert it to a skeletal mesh. We'll keep all the defaults and click Convert. Double-click on the skeletal mesh file to bring up the skeletal mesh editor. Let's quickly verify we have a clothing tab in our editor. We'll right-click on our mesh and select Create Clothing Data from Selection, then click Create. Right-click again on our mesh and select Apply Clothing Data. It's now time to paint our flag. So click on Activate Cloth Paint, then click on your skeletal mesh in the Clothing tab. So the dimensions of our flag are 100 by 100 centimeters, but if the wind changes to the opposite direction, then we're talking about a 200 by 200 simulation bounding box, roughly. So to give us some extra wiggle room, let's go for 300 by 300. So our paint value will be 300. We're going to start by painting the entire flag, and to make that easier, we'll use a brush radius of 50. Now that it's entirely painted, I want the edge of the flag that's going to be tethered to the flagpole to not simulate. So we'll drop our paint value down to 0 and set our brush radius to 5 and paint in our tether points. Let's exit paint mode and see how the simulation looks. That looks good to me. So we'll save our work and exit the skeletal mesh editor. Now let's drag our skeletal mesh flag into our scene and attach it to our flagpole. With our flag selected, let's set it up to collide with the pole when the wind is not blowing. Now enable these two settings, Collide with Environment and Force Collision Update. These must be enabled in order to collide with other actors in your scene. Time to add some wind to our scene. Go up to the plus drop-down and search for Wind Directional Source. And drag that into your scene. The longer light blue arrow represents the wind direction, so we'll rotate this to give us a proper blowing flag. The settings for the wind actor are pretty self-explanatory. By default, the wind speed is too low to make a nicely waving flag, so let's bump it up a bit. The speed value of about 12 should look pretty good. Let's play the simulation to check it out. And there you go. So that's going to wrap up this part of the tutorial on flag simulations. In the next part, we're going to take our skills one step further. We're going to model a curtain in Unreal Engine and apply a cloth simulation to it. Welcome to part 3 in this cloth simulation series. In this part, I'm going to show you how to model curtains in Unreal Engine, and then we'll convert the mesh into a cloth simulation. If you haven't watched the previous tutorial that covers cloth simulation basics, I highly recommend you check that out first. It's going to provide you with a good foundation and understanding of what we'll be covering in this section. First, we need to make sure we have our cloth mesh folder open. Now let's jump into the modeling tools and point it to our current folder. Select a rectangle shape. Set the width to 150 and the depth to 250. Set both subdivisions to 40 to give us a nice flowing curtain. To define the shape of our curtains, I created a 3-bar gradient texture map using GIMP. I'll show you how I did that later in this video. It's really easy. It doesn't have to be a 3-bar linear gradient. It could just as well have been a single linear gradient. I chose to use a 3-bar because the default single-bar linear gradient in GIMP produced a sharper fold that looked more suitable for a cloth blind than a curtain. Again, all these files are in the free project zip file that you can download using the link in the description. Back in the modeling tools, we next need to ensure our UVs are properly aligned. So click on the UV tab to bring up the UV options. Select Project UVs. In the Material Mode setting, select Override. And for the material, I'm going to select the 3-bar material gradient I made using GIMP. In the viewport, just adjust the texture so that we have an equal amount of black on each side of our mesh. Then click Accept. Next, click on the Deform tab and select the Displace option. We're going to use Displacement to shape our curtain folds. Set Displacement type to Texture 2D Map. Jump down here to Displacement Map and point it to our 3-bar gradient texture material. Set the UV scale on the x-axis equal to 2 to give us more folds. And finally, go back up to the top and set subdivisions equal to 0. This will tell the displacement process to not generate any extra polys for our mesh. If you prefer softer folds in your curtain, you can reduce the displacement intensity value. I like the default of 10, so we'll keep that for now. Then click Accept. Lastly, we want to be able to open and close our curtains during our simulation and later in our cinematic, so we need to adjust the pivot point. If you don't need this level of control, you can just place the pivot point wherever you want. Select the X-Form tab and then click on the Edit Pivot option. Click on the Center Position button to move the pivot so it's centered on the curtains. Then move it to the left or right side of the curtains, depending on which side you want your curtains to close towards. I'm going to go with the left side in this tutorial. Then click Accept. You can now test it out by switching to the Scale Transform control. We're all done modeling our curtains, so let's get out of modeling mode. Before we forget, let's rename this mesh to SM_curtains. We can now delete the mesh from our scene. Next, right-click on our curtain static mesh and select Convert to Skeletal Mesh. The defaults are fine, so click Convert. Double-click on the skeletal mesh file to bring up the skeletal mesh editor. Make sure you have a clothing tab in your editor. If not, go to the menu bar and click on Window, then select Clothing, and that'll bring it up for you. Right-click on your mesh and select Create Clothing Data from Selection, then click Create. Right-click on your mesh again and select Apply Clothing Data. Now we can start the cloth painting process. At the top, click on Activate Cloth Paint, then click on your skeletal mesh in the Clothing tab. This puts us into painting mode. Since the largest dimension of our curtain is 250 centimeters, doubling that to 500 should give us enough room for the simulation. So let's set our paint value to 500. A brush radius of 50 will help us cover a lot of area quickly. We'll start by painting the entire curtain. Next, we want the top portion of our curtain to be stiff. So let's set a paint value of 0 and reduce our brush radius down to 10. Now we'll paint the top portion of our curtains. Click Deactivate Cloth Paint to check out the simulation. If you need to tweak it more, click on Activate Cloth Paint to return to painting mode. Before we finish up here, let's just quickly assign it a curtain material I created earlier. Then click on Save and close this window. Now drag our curtain skeletal mesh into the scene. Before we forget, if you want your curtains to interact with other objects in your scene, we need to enable our collision settings for our curtain. Now enable these two settings, Collide with Environment and Force Collision Update. These must be enabled in order to collide with other actors in your scene. As a final touch, let's add a little wind to our scene. Click on the plus drop-down and search for Wind Directional Source and drag it into your scene. Rotate it so that the light blue arrow points in the direction you want the wind to blow. I'm going to have it blow towards the camera. With the wind component still selected, over in the Details panel, Set the wind speed to 3. Then click the Simulate button. You should now see your curtains blowing gently in the breeze. While still in simulation mode, switch to the Scale Transform control and test opening and closing our curtains as the simulation runs. And that concludes this tutorial on modeling and simulating curtains in Unreal Engine. Now, as promised, I'm going to show you how to create your curtain gradient in GIMP. You can create gradients in pretty much any 3D image editing application like Photoshop or even Microsoft Paint, so feel free to use whatever application you're familiar with. GIMP is a free image editing application that you can download from gimp.org. In this example, I'm going to use the 3.0 RC3 version. Once you have GIMP downloaded and installed, we're going to start by creating a new image. We'll use a resolution of 1024 by 1024. Then click OK. Next, select the bucket fill icon and select Gradient, or you can just press the G key on your keyboard. Then click on this gradient icon and look for the 3 bars sine wave gradient and select it. Now, starting on the left side middle portion of your canvas, hold down the Control key and left-click and drag out your gradient to the opposite side of your canvas. For our displacement, the white parts represent the outward folds of our curtain, while the black represents the indented parts. As you can see, this gradient has a nice gradual fading between black and white, and the white parts are not too white in the center. As I mentioned earlier, if you want sharper edges for your curtain folds, you'll want the center portion to be a really bright white. The rounded edge gradient in this list will give you exactly that look. I would highly suggest you play around with different black and white gradient patterns to see what you can create. Finally, to save our gradient texture map, go to File and select Export. Select PNG for the file type. Sorry about the jittery mouse movements. I just got a new mouse pad and it's really slippery and I'm trying to get used to it. Select the folder where you want to save your file. Then give it a name. Then click on Export. To import the gradient map into Unreal, just drag it into your content drawer. Then double-click on it to bring it up in the texture editor. Change the compression settings to grayscale. And uncheck sRGB. Then click Save, and you're all set to go. Well, that concludes this tutorial on modeling and simulating curtains in Unreal Engine. If you found this video helpful, please be sure to subscribe to the channel and hit that like button. Also, if you have any questions about what was covered in this video, or if you have any suggestions for a future tutorial, just leave me a comment below. Thanks for watching, and I'll see you in the next video.